Hello, today we're going to discuss equations for the decomposition of potassium chlorate lab. This is going to be part one. These are going to be the equations that we're going to have to deal with. When we get to the lake beds, that's going to be a totally different video, so watch that, watch and see when that comes out. So first, decomposition of potassium chlorate. We have to start there. So we got KClO3. This is our decomp reaction. It starts with 1 and we got to break it up. Now we do have to put this triangle over it. That triangle represents heat. So to decompose this as we did, we have to add heat. So that's where that symbol goes. So KClO3 gets heated up, and as we know, we collected O2, so oxygen, inside of those gas collected bottles, and what was left was KCl, so potassium chloride and oxygen. This is imbalance. This is what you're going to have to add in. Now I know some of you are also thinking, well, that's not the only thing we heated. We mixed KClO3 with manganese oxide. Well, where does that go? Where does that part? Well, that's actually a catalyst. And catalysts don't affect the final products. The only thing they do is lower the activation energy so the reaction happens quicker. That actually goes below the equation yield sign. So this is getting written as an MnO2. So this represents the catalyst. And this lowers the activation energy for it to decompose. So that's what we have first. We decomposed it. Now, what do we actually do for these equations when we added materials to burn? Right? Let's go to these. We did 3 different equations because we did 3 different tests. First, we had the wood splint test. We have the wood splint test. So we're going to have to add something to oxygen to get a final product. Now going back to biology, wood is coming from tree. Tree is made up of primarily water and carbon-based materials. So we're going to put a carbon here. So we've got carbon. We're adding that to carbon to oxygen, so just like you guys thought, it's going to create CO2, so carbon dioxide. By the way, make sure, going back to equation number 1, the decomp, make sure you guys and gals balance that. So that's the first equation for the test. Then we have the sulfur test. Now, once again, we're going to add just sulfur, that's all it is, plus SO2, and we get this, not a shocker, just like the wood splint test, up here, we're going to end up with SO2, sulfur dioxide. So, with this though, we didn't stop at SO2. Right after you took the sulfur, heated it up, put it inside the glass collecting bottle, you collected the gas, SO2. So this is a gas, as you know, and this is a gas. Well, with that, we took that SO2 gas, you took the bottle had water in it, in the liquid form. You agitated it by stirring it a couple times, shaking it, whatever you did with it. That infused the gas into the water. So if we're looking at our equation sheet, this right away doesn't look like how do we do this, but looking on your equation sheet, this is where it helps you out in that pink sheet. If we add SO2 and H2O, we actually come up with H2SO3, which is hydrogen sulfate or sulfuric acid. And this is in an aqueous form. Now, since this is an acid, we've got the H2 right here. So this is an acid. You also needed to do a litmus paper test. You should have had blue litmus and a red litmus test. Since this is an acid, this should have stayed red. The red litmus should have stayed red. But the blue, since it is getting reacted with an acid, this actually changes to red. This indicates the change to be an acid. So when you shook the sulfur dioxide with water, we created an acid, and this is actually considered acid rain. So when we have acidic rain comes down, it is actually H2SO3 in an aqueous form falling from the sky. So that's what we're literally getting hit with when there's acid rain. So we've got wood splint test, sulfur test, and the last test we have to worry about is the magnesium. So we have this magnesium. It's a solid. We actually combined it with oxygen using heat. We use the delta sign again. So magnesium plus oxygen. So we've got an active metal. We've got a gas. We've got MgO. Now remember back when we discussed how to write formulas, we've got to use our chemical periodic table. We've got to look at the charges. Magnesium has a 2+ charge. Oxygen's got a 2- charge. We cross them, drops the signs, and then we reduce. So it actually becomes MgO. Now once again, you'll have to go back. You'll have to balance this equation. So for the first part of this, we took magnesium, we heated it up with oxygen, we created magnesium hydroxide, or magnesium oxide. But that wasn't it. That wasn't it again. We actually took the product, the gas, took magnesium oxide, we added this to water, a liquid. So the gas put the liquid, we shook it, we agitated it, we diffused the magnesium oxide into the into the water, and we end up with, and this is where that chemical equation sheet I gave you guys early in the year helps you out. We put an active metal gas with oxygen, we put this with a water, we actually end up with MgOH, so magnesium hydroxide. Once again, we've got 2+, 1-, cross the charges, and we end up with Mg1OH2. So that's our second equation for the magnesium test. We're having magnesium oxide plus water yields magnesium hydroxide. We also did litmus tests. We had blue and we had red. When we did this, the blue should have stayed blue. The red, on the other hand, should have changed to blue. And when we do this, if we look back on the sulfur test, if blue changed to red, we have an acid. And since we know stuff about acids, the pH scale, this tells us then that we have a base. So we indicated it qualitatively by putting litmus paper in there. We quantified it by doing the chemical equation. And as we learned earlier when we talked about acid and bases, hydroxide for Chem 1 indicates it's a base. Both we had the indicators from the litmus paper and the chemical equation saying this is a base. Now, our next video, once again, is going to be what happens when we put H2SO3 into a lake bed that has a granite base and a lake bed that is made out of marble. But that's going to be for our next video. Thank you. If you want to go read through these, back it up and look at these equations again. Remember, these all have to be balanced if they're not. So make sure to go through them and balance the equations.